Hey everyone, welcome back to the channel. In this video, we are going to talk about something that really separates junior developers from experienced engineer: design patterns. These are proven solutions to common software design problems that make our system cleaner, extensible, and maintainable. You might have heard of terms like factory, strategy, or observer, but understanding why and how to apply them correctly, especially with solid principle, is where the real skill lies. In this series of design patterns, we are going to learn most widely used design patterns. And again, this will be helpful for interview because most of the question asked on design patterns as well. So first question comes, what are design patterns, right? So have you ever worked on a project where every new features breaks 5 old features, or where every developer has their own way of solving the problem? That's where design patterns comes to the rescue. Today I will explain what design patterns are, why they are important, and how they make your code cleaner and faster and easier to maintain with simple real life example. So what are design patterns? Design patterns are like blueprints or templates for solving common programming problems. They are not code you copy paste. They are proven ways of thinking. Just like civil engineer reuse bridge designs, developer reuse design patterns to build reliable softwares. Now, why to use design patterns, or what advantage it gives? Let's see the 5 main benefits of using them with relatable example. As you can see, first one is reusability. The first advantage design pattern gives is reusability. You don't have to reinvent the wheel every time, right? For example, if you already have singleton logger class, you can reuse that class across all microservices instead of creating new loggers everywhere. Right? Generally you do, right? Whenever you are writing code, so you're writing errors, maybe you're writing some statuses detail, you're logging those information maybe in a database or into a centralized logging, right? So you can write common logic in a single class using singleton design patterns, right? It saves times, ensures consistency. The second advantage it gives, maintainability, right? Make your code easier to change without breaking everything else. For example, in a payment system, maybe you're creating some payment system, right? If you use the strategy design patterns, you can easily add new payment type like UPI or crypto without touching existing code. Changes is isolated and there is low risk of bugs or feature breaks. Now third one is readability, right? So design patterns gives developers a shared vocabulary. Example, when you say this class is singleton or this uses factory design pattern, every experienced developer quickly understands the structure without reading every line. Now benefit it gives easier collaboration and onboarding, right? Now fourth advantage which design patterns gives is flexibility and extensibility. You can easily add new features, right, without breaking or changing existing system, right? That's one of the principles, a solid principle, open closed principles. For example, maybe you're generating some notification system and you have some notification third-party app which you're using, right? In future, if suppose you want to extend email or SMS or WhatsApp maybe, so without changing core business logic, you can easily add new features. So again, it helps in growing features, right? You can easily extend or grow your system. Now fifth advantage design patterns gives is testability and loose coupling. Design patterns helps separate concerns, making testing simpler, right? So, for example, with dependency injection principle, which is one of the open close principle, and factory pattern, you can easily mock or replace component like database or payment gateway during unit tests. So you can easily write unit test cases. So again, it will help easier automation testing and fewer dependencies. Now, in between, I am referring some solid principles, right? Dependency inversion principles, open close principles. If you have understanding of those principles, good. If you don't have any understanding, then I have created one more series for solid principles, so you can go through it and you can understand solid principles. So that's the overall benefits design patterns gives. Now, design patterns is grouped majorly into 3 categories. So they are grouped into majorly 3 categories. First one is creational pattern, right? So creation patterns handles how objects are created, right? Example, factory design pattern, builder design pattern, singleton design patterns. So these are the example of creational design patterns. Now don't worry about the explanation. I'm just explaining at high level, right? Anyways, I'm going to create separate videos for each patterns with implementation. The second category is structural patterns, right? How you define objects, right? Maybe you are defining object which composed of multiple subclasses, right? So this helps in composition. So adapter design pattern, decorator design patterns, these are the examples or subcategories of structural patterns. Now, third one is behavioral pattern. Define how object communicate or delegate responsibilities or work within each other. Maybe you are interacting with multiple classes or multiple objects. So again, this behavioral patterns helps in defining the structure. Again, strategy, observer, and command design patterns are one of the example of behavioral design patterns. So, in conclusion, design patterns aren't just theory. They are your toolkit for writing clean, scalable, and professional software. They save you from spaghetti code, or maybe you can say khichdi kind of code. It improves teamwork and prepare your project for growth. So in the next video, we will learn about creational design patterns, and I will start with factory design patterns explanation with real world example and implementation. Thank you for watching. If you enjoy this, please hit like and subscribe button and share this with your fellow developer. Thank you. Keep learning. Stay tuned.